Hola, welcome to Science Club. If you're having problems understanding how we get from here to here, then watch this short video and I will explain how to balance chemical equations and why it is needed. All you need is a pen and paper to follow along. In the first example, we have fluoride reacting with water to hydrogen peroxide and hydrofluoric acid. The reason we balance chemical equations is that the number of atoms on the left and right side are not equal, thus not being an equation. We see that by counting and writing down the number of each type of atom. On the left, we have 2 fluoride atoms, 1 oxygen atom and 2 hydrogen atom. On the right, we have 1 fluoride atom, 2 oxygen atoms and 3 hydrogen atoms. 2 of these 3 atoms come from hydrogen peroxide and the third from the hydrofluoric acid. The first step is to check the number of atoms on both sides. We have 2 fluoride atoms on the left and 1 on the right. We can see that the number of fluoride and oxygen atoms on the left and right side are not equal. Furthermore, we see that oxygen on the left side as well as fluoride on the right are bound to hydrogen atoms. By changing the number of atoms of one element, in this case oxygen or fluoride, we also change the amount of atoms of the bound element, in this case hydrogen. Important to know is that to balance chemical equations, we always write the coefficient by which we want to multiply the number of atoms in front of the element or molecule. Never in between, as that would mean we get a different molecule. If we put a 2 in front of hydrofluoric acid, we balance the number of fluoride atoms to 2 on each side. By doing that, we also get a total of 4 hydrogen atoms on the right side. To balance the hydrogen and oxygen atoms on both sides, we put a 2 in front of water. Thus, we get 2 oxygen atoms on both sides, as well as 4 hydrogen atoms on both sides. In the second example, we have aluminium reacting with oxygen to aluminium oxide. Once again, we check the number of atoms on both sides. On the left, we have 1 aluminium atom and 2 oxygen atoms. On the right, 2 aluminium atoms and 3 oxygen atoms. To balance the equation, we might think that 2 parts aluminium could react with 3 oxygen atoms to aluminium oxide. For that, we would have to use the fractional number 1.5 as a coefficient for oxygen. And while it is technically right, we have to use whole numbers 1, 2, 3, and so on. The reason for that is there are no half oxygen molecules. It is possible for singular oxygen atoms to exist, but 3 singular atoms of oxygen do not equal 1 singular atom and 1 molecule consisting of 2 atoms, as their chemical behavior is different. To circumvent fractional numbers, we can multiply the number by 2 and get a whole number. By also multiplying the other coefficients by 2, we make sure the equation stays balanced. If you found this video helpful, leave a like so more people can see this video. Do you have questions? Then leave a comment and I will try to answer them. See you next time.